Hi there, advanced hires. We're just going to do a very quick recap on the two data structures presentations that were one, and I've just edited them slightly. There's a couple of things to watch out for because there's a few changes, especially at the end of data structures one. Okay, so remember way back in June when we were talking about data structures, okay, we were recapping on the parallel arrays. So hopefully you'll be happy enough with the one-dimensional arrays, and if you give the first array a particular element ID and you give the same element ID to a second array, you should get the information that is tied together. So John is 23 in this example, James is 22, Mary's 20, Laura's 19. Okay, so that's what we mean by parallel arrays. There is no specific link. We're just using the numbers and hoping that the data is linked. Okay, it's fine as a solution, but it's not necessarily very robust, especially if we start sorting or deleting things. Okay, um, now data flow we'll come back to. Data flow is a big part of the course, just like it was in higher. Um, Especially with your project, you're creating your own data flow for this. Okay. Now records was a big part of higher, and we're going to use the BMI example quite a lot here. So and remember, to define a record in pseudocode, you choose the word record, then you give it its name, and then underneath it, you've got your variables with their data types after a colon, and at the end of that, you just say end record. Now, you don't have to be able to write that pseudocode. However, if you're asked to write a record in pseudocode, that's the easiest way. It's just that's the easiest structure to follow. Okay, you can kind of just go slightly off piste with this, as long as it's clear what the variables are in your record, what the record name is, and what the data types are for those variables. What is important, especially at higher, was creating it in Python. So I gave you the code again for this. So that is setting up your data class. And remember, data classes are the easiest way of setting up records, and it keeps them distinct from classes, object-oriented classes. Um, there's an example there. I'm not going to go through it too much. Okay, but if we want to store lots and lots of information, we can have an array of records. And just to kind of reinforce the record structure in the green box on the right there, but also if you are looking at pseudocode in an exam style question, if it says declare BMI details 39 as BMI, you've got to remember that the 39 elements is not 39, it's 40 because it starts at 0 and it goes to 39. Okay, so 0 to 39. As BMI. So it means that BMI details has 40 records in them, and each record is height, weight, and BMI. Now I'm going to show you exactly the same thing with classes in just a second, and I'm going to spend a bit more time going over that. Okay. Remember, if you're setting up an array of records, it's a good idea to have the name of the record inside the square brackets for a one-dimensional array of records, and then a loop after that. So for x in range 40, we'll create 40 BMI records from 0 to 39. Okay, and then you can just use the dot notation to be able to access the individual variables. Okay, whether you want to change it or display it. It's much more efficient with loops, but I'll let you read that back at your own leisure. Now here, array of objects, this is a new one that I added, and I wanted to make sure, because we talked about it in class, but I wanted to make sure that you had something to refer to. So got to remember that an object is something. I'm in a new classroom, so I've got nothing to hand. I've got a pen. There we go. So this is an instance of a type of writing implement. Okay, that writing implement has ink and an amount of ink, let's say. Okay, but someone else may have another pen, but if I'm using this pen and it's nearly run out, that doesn't automatically mean that the other person's pen has run out of ink as well. So you think about everything is encapsulated within itself. So the ink amount belongs to this pen. The ink amount that belongs to the other pen stays with the other pen, and we can't interact with that really very much. So an object is an instance of something called a class. Okay, so a class is a description of the objects and the attributes or the variables and the methods or the procedures that can be run on that particular object. So each object that you can see, Alice is an object, Bob is an object, Carol's an object, and they're an instance of a class of BMI. Okay, so they have the same structure, so they have a height, a weight, and a BMI, but those heights, weights, and BMIs can contain different values. Okay. Now, to just explain a little bit more about what a class is, because a class is the recipe that we've used to create those objects. So it's a blueprint for an object. So once that class has been defined, we can create any number of objects from that class description or recipe. The difference between a class and a record is that a class has attributes or variables and methods, functions and procedures, whereas a record only has attributes or variables. Okay, and you can see that in the example here on the left, we've got our BMI record from the previous slides, okay, the data class one. But on the right, we've got a BMI class. And the difference between the two is that the methods to set height and get height exist within the BMI class. So that means that any object that's created can also, we can say set height. So say there's Alice and Alice's height is defaulted to 0. We can say Alice dot set height 169, okay, or something like that. So you can set, you can get, and the methods are the difference between a record and a class. So similarly, if you're declaring an array of objects rather than an array of records, there's a slightly different way to do it. Okay, the left-hand side is exactly the same. So you've still got BMI details as the variable name. You've still got 39 as the number of elements because it's 0 to 39, which makes 40. And then the variable type is BMI because we've called our class the same as we called our record. The difference is the class structure. Now, this is from the SQA's pseudocode reference guide, language reference guide. And so they might describe a class in a question by using the word class, then the name of the class, then is. And then they use the curly brackets. And within the curly brackets, they've got the three attributes or variables that you can change. There may be methods in there as well, okay, but those methods would usually be described in something called a UML class diagram. If it's just a class structure, it's only one line of pseudocode. Now, difference between a record and a class again, if we're declaring it in pseudocode, there's something important to remember. When you have created a class, or an object, which is an instance of a class, you cannot reference their variables directly. Okay, so you can't say BMI details 0 dot height. That's not how you use classes. It's wrong. Okay, so I've left those lines in there. I've scored through them because what you should be doing is using the setter and getter methods. Okay, so in this example, we're setting the height of BMI object 0 to 1.6, and then we're setting the weight of BMI details object 0 to 62.3. Okay, so it's almost the same as records, but we're using setters and in future getters to return the values back. Okay, so watch out for that. So that's data structures 1. Let's look at data structures 2, which is all about two-dimensional arrays and linked lists. So in 2D arrays, remember it's a grid rather than a line of values or objects or records. Okay, and what we do is we are trying to create the columns and the rows in the correct order. Okay, so rows are the first number after the square brackets, and columns are the second number. So you do row first, then column. There we go. So in this example here, that's row 0, column 0. Down here is row 1, column 4, and down on the far right hand side, it's row 2, column 7. If we just try and print it out, you get quite a sort of complicated arrays within arrays list. Okay, but if you want to actually display it correctly, you use something a bit like this, where you use a loop to go through all the rows, and then within that loop you have another one that goes through each counter each time, and you build up a string, which is what row is on that line, row plus equals, and we're just building up a string that represents the entire contents of each of the columns. Okay, so that's a good thing to use. With linked lists are weird. They're stored in one-dimensional arrays. Okay, we can't get away from that. However, they're an abstract data type. Okay, an abstract data type means that they kind of exist in fuzzy, kind of like um, inside your head, but they're implemented using existing data structures. Okay, so we have something called a node. Each node in a linked list has a pointer that pushes the program to the address of the next node. And the good thing is that these nodes do not have to be in sequential order in the array, because you use the pointer to jump forward and backwards in the array to find the next node. The advantage of this is you could have an unlimited, so if you're traversing a loop, you could have an unlimited sort of loop of things happening just by pointing one pointer to something that was previously pointing to it. So you can kind of create a circle. There are five, but let's say four linked list operations that you need to remember and be able to implement or describe. Adding a new node at the end of a linked list, putting a node in between existing nodes in a linked list, deleting a node from anywhere in the linked list, the start, the end, the middle, or traversing. And traversing is maybe the easiest one, where you're just using you're looking at the first node, you're taking the pointer to the next node, you're looking at that node, you're displaying it, you're looking at the next pointer until you get to the end of the linked list. Okay, and this is something that you will be continually tested on. Okay, it only comes up as maybe a small part of your final exam, and you may not decide to use this in your advanced higher project. However, it's handy to know about. Okay. So you can watch the animation at your leisure. Remember the advantages and disadvantages. Linked lists are much more efficient because they use the arrays that have been created much more efficiently. So if something's deleted, it's not really deleted, it's overwritten with another node. And that node could be the middle, the end, the start of a linked list. And it only requires pointers to be changed, so you're not physically deleting things and making new lists and destroying old lists. Okay, so there's big advantages in memory and processor usage. However, downside is you don't really have the ability to index a particular node. You have to travel through from the start to the end to get there. So if you know that in reality, let's say we're looking at mammals, cat is the third node in the linked list. You don't really know where that is. So you have to start on node 1, get the next pointer, go to node 2, get the next pointer, go to node 3. There's the cat. And then you can display the details. Okay. So you have to go through it in a sequential way rather than a direct access. So that can take a bit longer. You need to store additional pointers, which is extra data, although it's quite small. And then the nodes may not be stored contiguously. So what contiguous means is like in a sequence, like side by side. So 2 follows 1, 3 follows 2, and so on. That's contiguous. Non-contiguous is when you've got 8 following 1, 3 following 8, 27 following 3, and everything's a big mess. Okay, so it has advantages and disadvantages, and that's usually what comes up in the questions. So that's our data structures for advanced higher. Hopefully that recap made sense. If not, post some questions in the private comments or bring it up on the lesson when I see you on Friday. Okay, hope this helps. See you later.